Welcome to A Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's video, I will explain one question from May-June 2019, and this is question number 4, and this question is about electric field. If you are not very clear about electric field or you always get stuck with electric field questions, watch this video carefully. It will help you to understand uniform electric field and also projectile motion in depth. Let's try to answer this question now. First of all, we have to figure out in this question what is given to us. So we have to figure out what is given. So how we can find out that? So this is simply we need to read question carefully. So we need to read question carefully to find out what is given. The second thing what we need to do is we need to also figure out what we need to find. So this is the second thing we need to find. Also figure out what we need to find. It means what we need to answer. So first thing, we have to read question carefully. So if we read this question, we will see that it is given to us. One plate has 0 volt, potential is 0 volt, and potential at other plate is equal to plus 900 volts. So what it means, it simply means that if we attach a voltmeter between these two plates, so what we will read from this voltmeter, that will be equal to 900 volts, and this is the potential difference between these two plates. Now, the next thing what we need to understand is we have to read, if we read this part of the question, we will find out this field is uniform field. So now, what uniform mean? Uniform field. So uniform field simply means that uniform field, we need to understand. Uniform field simply means E is same everywhere. E is same everywhere in the field. Everywhere in the field. E is same. So it simply means if I find value of E, let's say this point 1, and I choose another point, let's say I take point here close to positive plate, so this field is E2. If this field is uniform, it means E1 should be equal to E2. And also we need to understand if the field is uniform, the electric field lines. In this case, we are talking about electric field. So we will say electric field lines. So the lines, field lines has to be field lines. Field lines have to be parallel. So this is one thing. The second, also, they have to be equally spaced. Mean the space between lines has to be same. So we say these lines has to be equally spaced. So these lines has to be equally spaced. So the second thing is here. They have to be equally spaced if the field is uniform field. So now if we have understanding of these points, we understand what is uniform field, and if we can identify the pattern of uniform field, we should be able to answer part A, because part A is simply asking us describe the pattern of the field lines between the plates. So now let's try to answer this question now. How to write answer for this one. So we can also see here this question has 2 points here. So it means we need to write down 2 important points, 2 physics concepts. So this is how we can answer. So first thing, we need to write down the straight lines. So straight horizontal lines from the positive 0.90 kilovolts plate to 0 volt plate. Means we need to draw the lines from here, from positive plate to the negative plate. So the field lines has to be here. So he's asking you describe. So we no need to draw, but if you are interested, you want to see the patterns, you can see the field lines has to be this, like this. Start from positive plate and add. Start from high potential. This is the point you need to understand. Sometimes they can ask you in a different way. So you need to understand the lines always start from high voltage, high potential, and they go to low potential, low voltage. So this is the thing we have to be very clear. So low V. Okay. Start from high potential and add low potential. Let's try to answer part B now. Part B is asking us state the names of the two forces acting on the particle as it moves from point X to Y. State the names of the two forces. Now to answer this question, we need to find out where point X is located, where point Y is located. So this is the first thing we need to find out. So the next thing is we have to find out the forces acting on the particle. So simply we understand as the particle is located in the gravitational field and particle also have mass. So we can say the force acting on the particle is gravity, or we can say it's gravitational force. And as particle is located in uniform electric field and particle also has charge, it means there is a force on this particle due to electric field. That force we can call electric force. Now, if we have understanding of this, these two forces mean the force on the particle due to gravitational field and force on particle due to electric field. So then we can simply answer this question. So this is how we can answer, and this question has only 1 mark. If we write the names of these two forces, we will get 1 mark. So let's move on to next part now. So the next part is simply asking us, part C, it is given to us. Question is telling us only consider vertical motion of the sand particle, and also we need to show that time taken for the particle as the particle move from point X to Y is equal to 0.64. Now, as we only need to consider vertical motion, so along vertical, there is only one force is acting, that is gravity. So this is very important piece of information we need to understand to answer this part of the question. So now let's try to write down what is given to us and what we need to find. First thing it is given to us is that particle started from rest. So it means the u is equal to 0 meters per second. And as particle is only in gravitational field and there is no any other force acting on the particle, and the force acting on the particle is only gravity, so simply we can say that a is equal to G, because only force acting on particle is due to gravity. There is no air resistance. Next thing we can also find out the vertical displacement as particle move from X to Y along vertical. So the S, the vertical displacement, that is equal to 2.0 meters. So what we need to find out, this is what we need to find out. We need to find the time taken. So this is T, this is what we need to find out. Now, before we find the relationship between U, A, S and T, we need to be very clear about this one, that the force acting on the particle is, this force is constant or not. So in this case, the gravity is acting on the particle and this force is constant. So if this force is constant, it means A is also constant. Constant simply means that it has just one value. So if this is the case, then simply we can use S is equal to ut. This kinematic equation, simply we can say S is equal to ut plus 1 half at square. As in this case u is equal to 0, it means we can simplify this one. We can simply say that S is equal to 1 half at square. So if we have this understanding, simply we can just plug in values. S is given to us and G is also a constant, and we can simply figure out value for T, means we can find out time taken. So this is how we can answer. So just plug in values for S and for A, and we can find our final answer. So in this case, final answer is equal to 0.64, and this is the same as what we need to show that. So this is how we can answer this part of the question, means part B and part C. For part D, we need to find the horizontal component of the acceleration. We need to find the horizontal component of the acceleration. So this horizontal component we need to find out. So we need to consider the horizontal motion only. So as you can see here, along horizontal, we have the value of horizontal displacement that is given to us. And also, as the time taken, we have already calculated. Time taken for particle to move from x to y is the same as particle move from x to positive plate. So time taken is the same. So this is the key thing we have to understand to answer part D. So the time taken for particle to move from x to y is the same as time taken from x to positive plate. If we have this understanding, simply we can use kinematic equation and we can answer. So this is how we can answer this question. So as you can see here, what I did here, we have S, this is the horizontal displacement. We just plug in value of horizontal displacement, and this is the value of time we have already calculated. And as particles start from the rest, as I mentioned before, so we took U is equal to 0. And we have found value of horizontal acceleration. So this is our final answer. So this is how we can find out. So let's move on to part E now. Part E1 is asking us calculate the magnitude of the electric field. So to calculate magnitude of electric field, we need to understand uniform electric field. So how we can calculate value of E if the potential difference between two plates is given to us, and the separation between two plates is also given to us. So you can see here, as the potential difference between these two plates is given. So this is the potential difference, and the separation between two plates is also given to us. If we can find out these two information, then simply we need to use formula and we can calculate. As it is uniform electric field, so for uniform electric field, we simply need to use E is equal to potential difference between two plates divided by separation between plates. So this is the value of potential difference between plates, and this is the value of distance between plates. We just need to do basic calculations and we will get our final answer. So let's move on to next part now. So next part, E2. So let's try to answer E2 now. It is given to us the sand particle has mass m and it has charge q, and the question is asking us use your answers in D and E1. So you can see this is part D, we have found the answer, and this is part E. We have to determine the ratio between q over m, but we have to keep an eye on part D and E1. So here you can see we need to understand the relationship between A, this is the force, this is electric force. So let me write down again for you. Maybe some of you will not be very clear how we got EQ. This is in fact is the electric force. F is equal to EQ. And according to Newton's second law, A is equal to F over m, and our net force or resultant force along horizontal is electric force, that is equal to EQ. So that's the reason we use EQ divided by m. So what we did in the next step, we simply rearrange the formula. So we just rearrange this one, and this is our horizontal acceleration, and this is the value of E, as we have calculated horizontal acceleration here, and also we have value of E here. Just do basic calculations using your calculator. If you will use, you will get this final answer. So this is the ratio between Q and M. Let's try to answer part F now. In order to answer part A, first of all, we need to understand what question is asking us and what is given to us. So first of all, let's try to find out what is given. In this question, it is given to us, we have another particle that has smaller magnitude of the ratio Q over M than sand particle. And this particle is also released from same point X here. So it also means that this particle is in the same uniform electric field. Next question is telling us for the movement of this particle, state the effect, if any, of the decreased magnitude of the ratio on. So the part 1, F1, is asking us the effect of Q over M on the vertical component of the acceleration. So the vertical component, for example, we need to understand along vertical there is a one force is acting, and that force is gravity. So simply we can write down A is equal to F over M according to Newton's second law, and in this case the force will be equal to mg. And if we divide by m, so simply we can cancel m with m, so we will get A is equal to g. It simply means that A is independent of mass, so it simply means there is no effect. So there is no effect on vertical component of the acceleration. So this is what we need to say about this one. So this is how we can answer. We can simply say that there is no effect on vertical component of the acceleration because vertical motion is independent of mass. Now let's move on to next one. So the next one, we need to consider horizontal component of the acceleration, as we need to understand the horizontal motion, the force acting along horizontal, that force is electric force, as we mentioned, Fe, and Fe is equal to Eq. So if we use Newton's second law, we can simply say that A is equal to, means the acceleration is equal to F over m. In this case, F is electric force. So this is, we can write down here. So this is, But if we plug in value of electric force, so we can also write down in this form. So now as you can see here, so A is depending on E, Q and M. So E is the same because particle is in the same uniform electric field, but the ratio of Q over M, this ratio is decreasing. If this ratio is decreasing, it means horizontal acceleration will also decrease. So horizontal acceleration will also go down. So that's the reason we said horizontal acceleration will decrease if Q over M decreases. So that's all for today's video.